In large-scale industrial systems, such as Taobao's display advertising system, multimodal data has the potential to enhance recommendation accuracy. However, many systems still rely on sparse ID features due to the challenges and costs associated with deploying multimodal data. To address these challenges, a two-phase framework is proposed: pre-training multimodal representations to capture semantic similarity, and integrating these representations with existing IDBA-SED models. The production system architecture is designed to facilitate the deployment of multimodal representations, overcoming the limitations of IDBA-SED models that cannot capture semantic information contained within multimodal data. Previous attempts to incorporate multimodal data into IDBA-SED models have prioritized performance gains over deployment costs. But three practical challenges must be addressed: designing the pre-training task, scaling multimodal representations to large datasets, and seamlessly integrating multimodal representations with existing systems. The proposed framework addresses these challenges, and since the integration of multimodal representations in mid-2023, significant performance improvements have been observed in Taobao's display advertising system. This work provides valuable insights for practitioners seeking to leverage multimodal data in their systems, highlighting the potential of multimodal representations to enhance recommendation accuracy in large-scale industrial systems. The authors propose a two-phase framework for integrating multimodal representations into recommendation models. In the first phase, they employ semantic-aware contrastive learning to pre-train multimodal representations, enabling the capture of semantic similarities between items. This process involves constructing semantically similar sample pairs using user search queries and purchase actions, and drawing negative samples from a large memory bank. The second phase involves integrating these pre-trained multimodal representations into the IDBA-SED model. Two approaches are proposed: SimTier, which measures the similarity between the target item and items the user has previously interacted with, and multimodal knowledge extractor, Make, which optimizes the parameters associated with multimodal representations separately from the IDBA-SED model. The authors also discuss the design of their production system, which generates multimodal representations for newly introduced items in real time and ensures their immediate availability for the training infrastructure and online prediction server, achieving minimal latency. The proposed framework has been deployed in the Taobao display advertising system, leading to significant performance improvements. The authors propose a semantic-aware contrastive learning (SCL) method to pre-train multimodal representations for enhancing Taobao display advertising. This approach aims to generate representations that can discern semantic similarity between item pairs, attracting similar samples and repelling dissimilar ones. A tailored pre-training dataset is constructed by pairing a user's search query with the title of the purchased item for the text modality, and the user's image query with the image of the purchased item for the image modality. This strategy captures the dimensions of semantic similarity relevant to users in e-commerce scenarios. The info-NCE loss function is utilized, which measures similarity between representations using the dot product. The SCL method enables representations to capture fine differences between comparable items, crucial for recommendation models. The integration of multimodal representations into IDBA-SED recommendation models involves concatenating these representations with ID embeddings for both target items and past interacted items. Although performance improvements are modest, the authors observe that simplifying the usage of multimodal representations improves performance and will discuss more sophisticated strategies for constructing negative pairs in section 6.1.2. In the deep learning landscape, the deep interest network (DIN) model has been pivotal in various applications. However, its practical efficacy is often compromised by the complexity of integrating multimodal representations into the model. This paper introduces two innovative methods to address this issue: SimTier and multimodal knowledge extractor (MAKE). SimTier simplifies the utilization of multimodal representations by computing the dot product similarity between the multimodal representation of the target candidate item and the multimodal representations of the user's historically interacted items. The similarity scores are then partitioned into predefined tiers, effectively converting high-dimensional multimodal representations into a low-dimensional vector that encapsulates the degree of similarity. The Multimodal Knowledge Extractor (MAKE) module is designed to decouple the optimization of multimodal-related parameters from that of ID features. This approach addresses the discrepancy in training epochs required for ID features versus multimodal representations, as observed in the paper. The authors also discuss the limitations of directly integrating multimodal representations into the IDBA-SED model, which can lead to suboptimal performance due to inadequate learning of parameters associated with multimodal representations during joint training. Furthermore, they highlight the importance of training multimodal-based models over multiple epochs to achieve optimal performance. Overall, this paper presents a comprehensive analysis of the challenges and opportunities in integrating multimodal representations into deep learning models, providing insights into novel methodologies that can enhance model performance in real-world applications. The MAKE module is a two-step process designed to extract and utilize multimodal knowledge for enhanced recommendation systems. It comprises multi-page training to ensure the convergence of parameters related to multimodal representations and knowledge utilization by the downstream task. In the multi-page training phase, the center prediction task serves as the recommendation pre-training task. A DIN-based user behavior modeling module processes the pre-trained multimodal representations of the target item and historical interacted items, producing an output, VMake. This output is then fed into a 4-layer multi-layer perceptron, MLP make, to generate the logit, and the cross-entropy loss is optimized between the predicted click probability and the binary click label. For online deployment, the system must continuously generate multimodal representations for new items in real time. This is achieved through a system that initiates a request to pre-trained multimodal encoders to compute the multimodal representations for new items. These representations are then sent to the multimodal index table and retrieved by the downstream training systems and inference servers. An experiment section examines the integration of image representations into the center prediction model. The experiment setup includes the datasets used for pre-training and downstream integration, as well as compared pre-training methods such as CLIPO, CLIPA, and SCL. This setup aims to evaluate the effectiveness of the MAKE module in enhancing recommendation systems. In the pursuit of enhancing recommendation models, this research focuses on evaluating pre-training methods and their influence on click-through rate, center, prediction. A comparative analysis is conducted on various pre-training techniques, including CLIPO, CLIPE, SCL, and its variants without specific components such as triplet loss and MoCo. The findings indicate that the proposed SCL method, which integrates semantic-aware contrastive learning, surpasses other methods in terms of pre-training accuracy. Furthermore, the study explores different integration strategies for incorporating multimodal representations into the recommendation model. These strategies include vector, SIM-score, SIM-tier, and MAKE. The results reveal that SIM-tier and MAKE significantly improve center prediction performance, with the combination of both achieving the highest enhancement in GAUC and AUC metrics. The study highlights the significance of semantic-aware contrastive learning and the effectiveness of the proposed integration strategies in improving recommendation model performance. These findings contribute to the ongoing efforts to enhance the precision and efficiency of recommendation models, ultimately enhancing user experience and engagement. In the realm of Taobao display advertising, integrating multimodal representations into IDBA-SED models has shown promising results. A key challenge lies in capturing semantic information and addressing the cold start problem inherent in industrial recommendation models. To mitigate these limitations, the authors explore the effectiveness of incorporating multimodal representations into an IDBA-SED model. Figure 6a illustrates the strong correlation between pre-training metrics and click-through rate, center, prediction performance, demonstrating the efficacy of the proposed methods in integrating multimodal representations. The results show that multimodal representations can significantly improve center prediction performance, particularly for low-frequency items. The study assesses the relative improvement of multimodal representation across item groups categorized by frequency of occurrence, as shown in Figure 6b. The results demonstrate a significant improvement in all groups, with a more pronounced effect for low-frequency items. Furthermore, the authors investigate the impact of multi-pitch pre-training of the multimodal knowledge embedding (MAKE) model on recommendation model performance. Figure 6c presents the results, which demonstrate that multi-pitch pre-training effectively enhances model performance. The integration of multimodal representations into the Taobao display advertising system yields substantial gains in center, RPM, and ROI, particularly for new ads. The authors highlight the potential of multimodal data in addressing the limitations of ID features and provide valuable insights for those seeking to adopt multimodal-based recommendations in industrial systems. The study focuses on the two-phase paradigm for integrating multimodal representations into recommendation models, offering a novel approach to improving the effectiveness of industrial recommendation systems. Click-through rate, center, prediction models have evolved significantly with the advent of deep learning techniques, which have enhanced model performance. This evolution is marked by the development of various deep learning models, including wide and deep learning, deep interest network, and deep neural networks for YouTube recommendations, among others. These models have demonstrated improved accuracy by incorporating visual features and user behavior data. However, deep center models are not without challenges. Overfitting remains a significant issue, and addressing it is crucial for achieving reliable predictions. Potential solutions include regularization techniques, early stopping, and data augmentation. Another critical aspect is the need for fast inference speed and low latency in real-world applications, emphasizing the importance of model calibration. Contrastive predictive coding has emerged as a promising approach to enhance model performance. By capturing complex patterns in user behavior and item attributes, this method improves the accuracy of center predictions. Furthermore, the integration of multimodal data, such as image and text features, holds promise for future research. The development of more efficient algorithms and the exploration of new deep learning techniques, such as graph neural networks and transformers, are also essential for further improving model accuracy and efficiency. Ultimately, the future of center prediction lies in the development of more accurate, efficient, and scalable models that can meet the demands of real-world applications. By addressing the challenges and limitations of current models, researchers can unlock the full potential of deep learning in center prediction, leading to more effective online advertising and personalized recommendations.